Hello, so today we are going to do this problem called minimum amount of time to collect the garbage. It's part of weekly contest 381, 308, which is this week's contest. So the problem says we get an array of strings representing garbage where garbage at position I is basically the types of garbages at the ith house. So we have a list of houses and each position in garbage is what types of garbage is at that house. So, and the types of garbage are presented with MPG, with M being metal, P being paper, and G being glass, yeah. And so we picking any one of these, any single garbage takes 1 minute. And we are also given a zero indexed integer array travel, where travel at position I is the number of minutes we need to go from house I to house I plus 1. So we have two things that contribute to the time: picking one garbage unit and traveling from one house to the other, right? Now there is another condition, which is we have 3 garbage trucks, and each truck can take only one type. So it can only either take metal, paper, or glass. You can't have one garbage truck taking different types. And the way garbage trucks move is from house 0 all the way to the end. From house 0 to 1 to 2 to I to I plus 1 until the end, right? And it goes in order. However, it doesn't need to traverse all the houses. So for example, let's say we have metal only in house 1 and 2, and we have 4 houses. 3 and 4 don't have metal. So the truck that is picking up metal garbage can stop at house 2, right? Yeah, basically. And while one truck is driving, the others two cannot do anything. So we have to count the minutes differently, like consequently. We can't do it in parallel. So that's basically the problem. And what we want is to return the minimum number of minutes we need to pick all garbage, right? Yeah, so essentially, let me just summarize to give you the gist of the problem. So we have a set of houses, and each of them has some garbage. For example, here, house 0 has 1 unit of glass, house 1 has 1 unit of paper, and then we have 3 trucks. It doesn't matter really the number of trucks. What matters is that we can't pick multiple garbage units in parallel, multiple types. And the trucks travels from house to house, and we have the travel time here. So 2 is to travel from 0 to 1, 4 is to travel from 1 to 2. And what we want is the overall minutes to pick all garbage. And the 2 things that contribute is picking a unit of garbage and the travel time. So that's essentially the idea. Now let's take a look at the example. So we have house 0 here has only 1 unit of glass garbage. House 1 has 1 unit of paper. House 2 has 1 unit of glass and 1 unit of paper, and then you get the idea like that. So what we can do is, for the first one, we can have the first one pick only the glass garbage. So it picks this, and these 2. So picking this one takes 1. Picking this one takes 1, picking these 2, because the same type, we can pick them both at the same time, so this takes 2. So that's just the time it takes to pick the garbage units. Now, the time it takes to travel, right? So we need to travel, to get to this one, from this one, we need to travel here and then travel here. So overall, it's 2 plus 4, so 6 here. And then to get from here to here, it's 3, right? So 9 plus 2, that's 11 plus 1, 12, 13. So 13 just to pick G, right? And now, so we have 13 here. And now for the paper, well, we need to go from 0 because we start at 0 to P, right? So that makes it 1. And then here, we need 1 as well, but we can stop here. And the time it takes to travel, 6 here, pretty much. So 6 plus 2, that's 8. So we need to add 8 here. And that ends up being 21, right? So that's kind of the idea. Yeah, now let's see how we can solve it. Okay, so let's see how we can solve it. So this is the first example that we have, and you can think of it as basically we have house 0, let's call it H0, then we have house 1, and then we have house 2, and then we have house 3, right? So this is the idea. Now, if you, what we have is here we have G, P, GP, and JJ, right? And the distance here is 3, 4, 3. 2, 4, 3, right? So intuitively, what do we need here? Maybe we can make a couple of observations, right? So what do we care about? The thing that we care about is the count for each type at each house, right? So that's the first thing. So count, so we can have maybe some kind of, how do we store that? So basically we need count for each type in each house. So that's one thing that we need. So that will allow us, because picking one garbage would take 1 unit. The other thing that we need is this travel here. How can we account for it? For this case, for example, the last J is here, right? So no matter what, we'll need to traverse all houses, right? So no matter what to pick, for the truck that is picking the glass garbage type, we will need to traverse all of them. So 2 plus 4 plus 3, right? 6 plus 3, 9, right? And so, and if we take a look at the one that is picking the paper, well, that one anyway needs to go all the way to here, to the last P, because it needs to pick this P going from 0, and it needs to pick this one as well. So that one, but it doesn't need to. For the second one, we only need to go up to here, right? So this would be 2 plus 4. So this is only for travel time, only counting the travel time. So here, the other observation is that for travel, what matters is distance to last house with that garbage type, right? So that what matters. Just to drive this point home, let's try the second example that we have. So the second example, in the first house, we have H0 that has 2 M's, so 3 garbage of metals. And then here we have H1 that has PGM, and the second one, H2, has GP. And those are what we have. And then we have, in terms of size, in terms of travel, so let me just make this super clear. So this is J, and then in terms of travel time, this is 3, this is 10. So the first truck needs to take these 3, but it can stop here if it's taking M, right? It only needs to go here, it doesn't need to go to the third one, so we only care about 3. For the second one, that is picking, let's say P, so this one is picking M. And if we go for the second one that is picking P, it needs to stop here because this is the last P, because anyway it needs to go to here to pick this one, and here to pick this one. And so this here needs to do 3 plus 10, 13, and this is 4P. For G, we need to go here and we need to go here, so it needs to go here for J. And so that would be 3 plus 10 as well. So 13, okay? So you can see here what matters is the last house the truck stops at. And then the second thing is just the count of how many it picks at each house. Okay, so let's take this example here and see what do we need. This house here. And see how can we execute now our algorithm, right? So the first thing is we need to count the occurrence of each character, right? So what this would mean is that we need a count for each house. So what we can do is just have an array of count, basically like this, and each one of them is a count map. So we have that first position, second position. We have 4 houses here, so for each one we need to have like this. And this would be just array, 0 for the first house, the second house, 1, position 1, 2 for the second house, and 3 for the third house. And now what do we put in those, right? So for for each count, we want just the letter and then how many times it occurs. So for the first house, G occurs 1 time, P 0 times, and yeah, metal 0 times. But we don't need to worry too much about metal because it's not here. And then here, no G, so G0, P1, and then M0, and then here G1, P1, and then M0, and then here 2G, and the other ones are zeros, right? So once we have the count here in each one of them, the other thing we care about is the total. And total here, sorry, not the total, but the last house we stopped at, because that's what we need to add the distance to that last house, right? So what do? We can just have a map as well that maps basically each character to how, where is the last house. So for J, last house is, so this is 0, 1, 0, 1, 2, 3. The last house is 3. For P, the last house is 2. And then for M, well, no last house, so let's just pick 0 if it's, so if it's no last house, let's actually default to -1, because if we default to 0, then it's distance to the first house, right? Okay, so now that we have these two, how can we calculate the number of minutes? Well, it should be easy now, because what we can do is just go through for each, remember each track takes one type, right? So we can just go over all the types, right? So maybe call this character in MPG, right? For each character, we will see how much we can take of minutes. So let's just have our minutes here. Okay, so let's count here. So we need to go through all the houses, and for each house we need to count how many of that type there are, right? So we need to go through the houses. So we go first to house 0, and we check how many J's are there, right? So because actually let's just change the order here and have it be GPM, right? So we find that there is 1, so we need to add it. Then we go to the second house, is 0, so nothing to add. It's 1, so we add it. And here it's 2, so we add it. So this is just the time to pick the garbage unit. So we add that first, and then once we are done traversing for I, right, we need to add the travel time, right? So now the only thing missing is the travel time. So what we can do is for each house, we can check. So for house 0, we can check if the last house where J is available, if the current house index is smaller than the last one, that means we need to travel to that house, right? Because we need to go all the way to the last one. And so we add its travel time if it's smaller or equal, okay? And so what we do here is we add, because I is equal to, we are at house 0, and 0 is smaller than the last one for this house, which is 3. It's smaller, so we add it. So, which means here, let me just do this here. So if it's smaller, we need to add it, and 1 is actually smaller than 3. So if I is smaller than last C, that means we need to add 2 minutes, the travel time to I. Right? Because we need to go to it if it's smaller than the last one for that type. And here, it's just for every count. We need to add, this is count for I, for that character. And so here for house 1, that means we need to add for house 1 the travel time, which is, for house 1 is 0, right? So we can just add 0. So initially for our travel array, we can just add 0 to account for the first house. And now for the second house, when we visit the second house, it's also smaller than 3. 2 is smaller, 1 is smaller than 3, and so we add the travel time to it, which is in our case here, the travel time is 2, right? So we add 2. And then if we go to the third house, which is index 2, it's still smaller, so we add the travel time there, which is 4. And then when we go to the last house, the travel time is 3. 3 is equal to 3, so this is still valid, so we add it, right? So, and now we get the minutes, so this is the time it takes to pick J's. And then now we add the time it takes to do P. So now we go to the second iteration for P. We go to the first house, P equal to 0, so nothing to add. Here it's equal to 1, so we add 1. And then we go here, it's equal to 1, so we add 1. Here it's not there, so we add 0, right? And now we need to count the travel time. I'm doing it like separately, but it's like in the same iteration. So that for the first house, 0, what's the last one for P? The last one for P is 2. So 0 is smaller or equal to 2, so we need to add that, which is 0. And then for house 1, it's smaller or equal. So we need to add the travel time for 1, which is 2. And then 2 is smaller or is equal to 2, so it's valid still here. So we need to add the travel time to 2, which is 4. And that's pretty much what we need here. And so yeah, this is pretty much that's pretty much it. Now we go to M. M doesn't have all zeros, so and the last house is -1, so we don't need to worry about it. So we add nothing for M. Okay. And for M, here we don't need to add anything because it doesn't. Last is -1, so it's not there, so 0. And then also there is no occurrence for it in any of them, so it's just 0, right? So that's the idea, pretty much. Count the number of occurrences of each type in each house, and then the last to track the last time the last house type is in, and then after that we just execute this loop to go through each type, and then for each type we go through each house and count, essentially. Yeah, so that's the gist of the solution. Now let's code it and make sure it passes test cases. Okay, so let's write down the solution. So the first thing we need to do is what we said earlier, which is that we want to add 0 plus travel. This is so that we can easily do travel at position I, and that would be just the time it takes to travel to house I, because if we do that, that way we can just do travel 0, and that will point to equal to 0 for house 0. Right, because initially in the input we don't have house 0. So that's the first thing. And then the second thing is, of course, we need the length, right? And then we need our map, which we said would need to count this. Basically, count stores number of each type for each house, right? So basically, how many garbage units of type G, so glass, in house I. And so that would be count, we would initialize it to a list of maps, right? So that basically count I is for house I. And so that would be collections. We'll initialize it to 0 so that if, let's say, metal doesn't occur in house 2, the value is 0. And this we need to do it for every house. So, and then we need last, which basically last C would be last house where a specific type C is in, right? So that would be, we'll initialize that one also to a map. So that would be, so this would be the index of the last house. So let's, and then we'll do a lambda here, and we'll default to -1. Okay, -1 we are defaulting here just so that we don't set 0 if it's not present, because 0 is a valid house index, right? And now we will fill count and last. So to do that, we'll go through every house, right? And then go through every type. Let's call it just MPG, and this would be C. And then we would want to store for I, right, the number of occurrences of each character. And remember, the input has something like, maybe at house 0 we would have something like this. So if you want to count how many M's in this string, we can just say this is equal to garbage I, and count how many occurrences of C. You could also do it just with a for loop and count, right? And now to check last, we want to check if this house is the last occurrence of M. So as we go, we need to update the last occurrence, but we need to check if it's in there, If it's in there, let's update last. So now last of C is equal to I, and then if we, let's say this is 2, we go to 3, we found there is M again, then we'll update this to 3, right? So each time as we go, we update. That way we end up with the last house index here. Okay, so next step, we'll do just a simulation where each loop will represent the time truck goes gathering one type from all the houses, right? So the first iteration, let's say for M, we will count the number of minutes it takes to gather all units of type M from all the houses. So that's what we'll do here. So we'll start out with minutes equal to 0. And then we'll go through for each type. Each type will be one pass for a truck. And so let's call it C, BG. And then we'll go through every house to pick all of it. And each time we just want to add first how many times it takes to pick the units, and that's just count IC. And then if this is not the last house, that means we need to travel to it, right, to pick whatever count of P or G is in that house. We didn't need to do it here because the count will default to 0 anyway, so we don't need to check. So here we need to add the time it takes to travel to that house, and now we can do travel I, as we said here, okay? And then at the end we can just return minute. And let's submit. Cool, so that passes test cases. Now, actually, one thing we can do is simplify this a little bit here. Because if we take a look at this here, let's take a look at the example. What you can notice here, each time we are adding the count of each character in each house. And the count over, so we are just summing the count of all the characters in all the house. And that's actually just summing all the lengths, right? Because the count of a character, of each character, that's just the length. So what we are doing is just the sum of the length of each X in garbage, right? Of each string in garbage. So instead of doing the count like this, I'll just remove this first. So we don't need this count map. So actually, minutes, we can initialize it to just the sum of the length. So map of length on garbage for each place in garbage, for each string in garbage. So this would be the time it takes to take all units. And that's just, instead of doing it separately for each truck, we just do it at the same time. That's the first thing. Now, what about last? Can we optimize it? Yes, we can optimize. We can simplify last calculation here because, let's see here. Let me show. So if you take this is the travel time. So for G, we know the last house is, these are the indices. So let me just add them here. 0, 1, 2, and then here we have 3. So for G, we know the last house is 3. So we need to traverse all of them. So it's actually the sum of all of them. So if we take the prefix sum, 6, 9, you can notice here, this is, let's call it prefix. The time it takes to travel, to do all the travel required for G, is just prefix at position last of G, right? And so if we take the prefix sum, then we don't need to calculate, go through the travel and calculate again. We can just do one lookup, right? So that's exactly what we'll take advantage of here. So here we need prefix, which would be just equal to, of course, prefix, you could calculate it yourself by just doing a loop with I plus 1 with prefix of I plus 1 is equal to the prefix, or prefix of I is equal to the previous one plus the current one we are looking at, travel I. So you could do that with a loop, but easier in Python, I'll just use accumulate function, which just does that. So let me show you what I mean by that. So if we go to the, here, let's call this numbers or travel, right? So if we accumulate travel here, and just convert this into a list. So this gives us the prefix sum we want. So that's just a function we can use. Accumulate is in error tools. So if you don't want to use that, you could do it yourself, but we'll just use that for now. So list of accumulate on travel. We'll convert it to a list because otherwise it's without a list, it's an ether tools object, right? Okay, so now that we have the prefix, we know we can just take the last house and just pick the index, use the index. Yeah, so that's what we'll do here. So instead of doing this here, we know just the last house is going to be, so here we're going through every house and adding the travel. So instead of doing that, we'll just say last house we know is equal to the value in last for that character. And what we add here, we can just add prefix for that last house. What I said here, right? Now I deleted the calculation of last. So how do we calculate it in a simpler way? So last actually is just for that character, the last I, for I in, so we'll go through the garbage, all the garbage in each house, right? So we'll enumerate it. Right, so this would be, maybe call it X, and X would be just whether it's a MMPG or GP or that, and each time we update in the loop, right? And what is C? C is just the characters for that house, right? So just X. So this is similar to the loop we were doing before, it's just in one line. Yeah, and we don't need to assign 0 anymore here because now we are doing a prefix sum, so we can delete this. And we just need here to initialize this with 0. So we start out with 0, with value 0, instead of doing it what we did before. And that should be it. So we'll run this. So you can see this is a lot simpler, hopefully, than the previous solution. Yeah, so sometimes, like in this case, one of the characters may not be there, so we need to handle that. So we could do if C in last. Otherwise, just do the 0. Okay. Okay, it looks like there is. Yeah, so I reset minute. I shouldn't because we have the sum of the time it takes to get all the units. So let's run this. And let's submit. Cool, so that passes test cases. Yeah, so that's pretty much it for this problem. Yeah, please like and subscribe and see you on the next one. Bye.